This is section 4.2, multiplication of polynomials. There are actually five objectives here. One would be multiplying any two polynomials, and then using the FOIL method, which I may skip, and I explain why. And then you use the square binomial and how to multiply a sum and a difference of the same two terms. And then last, the function f described by second degree polynomials, how to find and simplify notation like f of a plus h and f of a plus h minus f of a. So we'll explain all of this. Now, the one important fact about multiplication of polynomials is that to do this correctly, you have to know how to multiply monomials. Because multiplying polynomials is simply a sequence or a series of multiplying monomials. And an important part of that is to understand the rules for exponents, especially the product rule for exponents. And again, that goes back to page 26 in the beginning of the book. And again, I certainly hope that you have reviewed that section, page 26, and it begins on page 13. But it would be really, really quite important to understand those rules for exponents. Otherwise, it's very difficult to do. And so I'm just going to review that little bit here, not extensively, but the rule for exponents, the product rule basically says that a to the m, where a is the base and m is the exponent, times a to the n, in other words, if the bases are the same, is a to the m plus n. For example, if we looked at numbers involved, like 2 to the third power, times 2 to the 7th power, and again, the bases are the same, the exponents are different, is 2 to the 3 plus 7, or 2 to the 10th power, whatever that is, 1024. Okay, so this rule is really, really important to understand, and later on we have an occasion also to understand the power of a power rule, and that is a to the m raised to the nth power is equal to the a to the m times n. So if we replaced a with a number, let's say 4 to the third power raised to the second power, that means 4 to the 3 times 2, or 4 to the 6th power, whatever that number is. Okay, I just want you to understand how this power to a power rule works. So these two, this will be used later on, but this will be used right away. So this would be really, really important to understand, the product rule for exponents. So we begin with a simple exercise. Multiply the monomial 9y squared by minus 2y. So a good way of thinking about it is to take the coefficients 9 times minus 2 times y squared times y. Okay. It doesn't mean you have to write it this way, but it's one way of going about it. So then 9 times 2 is 18. And from the product rule, we know that y to the second times y to the first, in other words, as an implied 1, is y to the third power, or the minus 18. It's a minus 2. 9 times minus 2 is minus 18. So minus 18 y to the third. The next exercise is very similar. So we can write that as we take the coefficients, 4 times 6, and then we have x to the third, and there's an x to the fifth, and then we have y, and then there's a y squared times y squared. So then the answer is simply 4 times 6 is 24, and x to the third times x to the fifth is x to the 3 plus 5, or x to the 8th, that's the product rule for exponent. Then y, or y to the first power times y to the second power, is y to the 1 plus 2, or y to the third power. So it's 24 x to the 8th, y to the third power. And the third exercise is very similar to what we just did. Again, if we take the approach, we write the coefficients first. We multiply the coefficients. So that's minus 5 times 18. And then we have an x here, and we have an x to the third there. Remember, it's all multiplication. And then there's a y to the 7th, right here, y to the 7th, times a y squared. And then we have z to the 4th, times z to the 4th, times z to the 8th. So then minus 5 times 18 would equal minus 90. And x to the first times x to the third power, that's a 1 here, so 1 plus 3 is x to the 4th. Here we have, again, using the product rule, y to the 7 plus 2 is 9, y to the 9th. And here we have z to the 4th times z to the 8th, so then that's z to the 4 plus 8, or z to the 12th power. And again, there's implied multiplication here throughout. So it helps to be organized. Now, do you have to do the intermediate step? No, you don't have to. Is it a good idea? Yeah, it probably is, especially when you're starting out doing these exercises. Well, let me write the final answer for the previous exercise. There was 24 x to the 8th y to the third that's 3 here. Okay, we get all the answers here. The next exercises will make use of the distributive laws, and again, they're explained in more detail on page 21. If the distributive laws or properties, if you're not familiar with them, please go to page 21 and study them and look at the examples and do some of the examples so that you'll be sure to understand them. Okay? It's a prerequisite to multiplying polynomials, and so we'll be doing that right away here. So the way the distributive property works is we multiply the term outside the parentheses times each term inside the parentheses. Okay? So in other words, this then becomes minus 3y times 2y plus minus 3y times 6. So now we are multiplying monomials. So minus 3 times 2 is minus 6. and y times y is y squared. And 6 times minus 3 is minus 18. So minus 18y. Now sometimes people want to combine these two terms, but obviously they cannot be combined because even though they have the same variables, the variables are raised to different powers. So this y is raised to the second power, there's only y to the first power, so in other words we cannot combine these two terms. The next example is very similar. So we multiply 2xy times the first term. So that's 2xy times 4y squared minus, because there's a minus there, 2xy minus 2xy times 5. And then what we've learned from above, how to multiply monomials, we multiply the coefficients. 2 times 4 is 8. And there's 1x. And then y times y squared would be y to the third. And now we multiply 5 times 2 is 10, but there's a minus sign, so it's minus 10. And then xy. So that is the result of multiplying the monomial 2xy times the binomial 4y squared minus 5. So in other words, we multiply term by term. That is the distributive law. Again, page 21 gives you all the details about it. And again, if you don't understand this, then please go back to page 21 and you will understand it after you studied it. So how do we multiply two binomials? Well, it's really the same procedure. We multiply the first binomial 5x squared minus 4. So that is a factor 5x squared minus 4 times the first term. So it is this binomial times x plus 5x squared minus 4 times 3. So 5x squared minus 4 times 3. And now we are applying the distributive property from the right side. We multiply x times 5x squared. So I'm going to put an intermediate step in for you. The 5x squared times x minus 4 times x. So we'll multiply x times minus 4 times x. And then for the next term, we multiply 3 times 5x squared, or 5x squared times 3. And then the last term would be minus 4 times 3. So finally this becomes then 5x squared times x would be 5x to the third power. And minus 4 times x is simply minus 4x. And then we have 5x squared times 3 would be 15x squared. And then minus 4 times 3 would be minus 12. And so then finally we have 5x to the third plus 15x squared minus 4x minus 12. So there would be our final answer for the product of these two binomials. And I would just encourage you to do lots of little drill exercises until it becomes clear to you how this all works. So practice, practice, practice. Let's look at the next example, which is similar. It's 2y plus 3 times the polynomial 3y minus 4. So again, we multiply 2x plus 3 times 3. So that's 2y plus 3 times 3y. And with minus, because there's a minus sign here, 2y plus 3, sorry about that, 2y plus 3. So we have 2y plus 3 times 3y, minus, there's a minus sign, 2y plus 3 times 4. And now we apply the distributive law from the right side. So we multiply 2y times 3y plus 3 times 3y. And now we have 4 times 2y, but with a minus sign, so minus 2y times 4 minus 3 times 4. The minus goes to both terms. So then we finally have 2 times 3 is 6. Y to the second power, and 3 times 3y is 9y, and 4 times 2y is 8y with a minus sign, so minus 8y, and then we have minus 3 times 4 is minus 12, and now we combine like terms, and there's only 6y squared, so only one term is y squared, but here two terms is y. So 9y minus 8y is 1y, or simply y, and then minus 12. So that would be the answer for the second exercise, 6y squared plus y minus 12. So far we've multiplied a monomial times a binomial, and then now we multiplied two binomials. The next step is where we're going to multiply a binomial times a trinomial. So that'll be the next exercise, number 8. So where we multiply p minus 3 times p to the third plus 4p squared minus 5. And it's basically just an extension of what we did a moment ago. So we multiply p minus 3 times p to the third, so p minus 3 times p to the third, and we multiply p minus 3 plus p minus 3 times 4p squared, and p minus 3 times 5, but there's a minus sign, so minus p minus 3 times 5. Okay? So that sets it up now for doing the work. of multiplying the binomial, each binomial times the monomial. So let's see what we get. We get p times p to the third. So I'm going to take one step in between. P times p to the third. And then minus 3 times p to the third. Minus 3 times p to the third power. And then we have p times 4p squared plus p times 4p squared. And then we have minus 3 times 4p squared. And now we have minus, and then 3 times p, and then we have minus 3 times minus 5. There was a minus 5, yeah. Minus 5. Okay. So, now we have p times p to the third, which is p to the fourth power, minus 3p to the third, minus 3 times p to the third power. And then we have p times 4p squared. So p times p squared is p to the third. So we have plus 4p to the third power. And then minus 3 times 4 is minus 12p squared. And then we have minus p times 3, so minus 3p. And now we need to watch out for the minus sign. Minus 3 times minus 5 is positive 15, but it has a minus sign, so it becomes minus 15. Now we look for some like terms we can combine. Well, there's 1p to the fourth, and that's all. And then there's minus 3p to the third plus 4p to the third. So minus 3 plus 4 is 1, or simply p to the third power. And minus 12p squared, minus 12p squared, minus 3p, minus 15. So let's go over the steps again. So we multiply the binomial p minus 3 times p to the third, and p minus 3 times 4p squared, and p minus 3 times 5, but with a minus sign in front. So that gives us then p times p to the third, or p to the fourth, and minus 3 times p to the third, minus 3p to the third. And then 4p squared times p is 4p to the third. And then minus 3 times 4p squared is minus 12p squared. And then we have 5 times minus p would be minus 5. So let me just correct that here. So p times minus 5, minus p times 5 is minus 5p. And then 5 times minus 3 is minus 15, with a minus in front gives us a positive 15. So finally we have, by combining like terms, we have p to the fourth plus p to the third minus 12p to the second power minus 5p plus 15. The next exercise is very similar. Here we multiply from the right. So our binomial would be x minus 4 times 2x to the third. So 2x to the third times x minus 4. And we have 4x times x minus 4. Then minus 5 times x minus 4. So now we use the distributive law again, and 2x to the third times x would be 2x to the third times x plus 2x to the third times minus 4. And then we have 4x times x. And then we have 4x times negative 4. And then minus 5 times x and minus 5 times minus 4. So now we just need to multiply these monomials, and so there would be 2x to the third times x is 2x to the fourth power, and 2x to the third times minus 4 is minus 8x to the third, and 4x times x is 4x squared, and then 4x times minus 4 is minus 16x, and then minus 5 times x is minus 5x, and minus 5 times minus 4 is plus 20. So when we look at the last line here, we can combine some like terms, but there's only one 2x to the fourth, so 2x to the fourth minus 8x to the third power plus 4x squared, and minus 16x minus 5x is minus 21x, and then plus the constant term of 20. So this then is our final answer. So as you can see, it is really a matter of keeping track of all the different terms. And again, it takes some focus and some practice, obviously, also. But at the basis of what we did here is really the idea of multiplying monomials and knowing some of the basic properties, such as the product rule for exponents and the distributive laws. Here's a general strategy for the product of two polynomials, and that's to multiply two polynomials, p and q, select one of the polynomials, say p, then multiply each term of p by every term of q, and then collect like terms. So let's apply that to the next exercise, number 10, and let's follow through with that. So this is our p, that's our polynomial q. So that means we multiply minus 4x to the third times 2x squared. So minus 4x to the third times minus 2x squared, and then minus 4x to the third times minus 3x plus minus 4x to the third times plus 6. And then we select this term here, plus 5x squared times minus 2x squared plus 5x squared times minus 3x plus 5x squared times 6. Then we use the next term, minus 2x, so plus minus 2x times minus 2x squared minus plus minus 2x times minus 3x plus, again, minus 2x times 6. And then we have 1 times, I'm going to write it out. It may seem silly, but I'm going to write it out. 1 times minus 2x squared plus 1 time minus 3x plus 1 times 6. So you see we've got all the factors lined up, minus 2x squared and minus 3x and minus, where's the minus 2x here, and the 1. So now all we need to do is multiply the monomials. So minus 4 times minus 2 would be positive 8, and x to the third times x squared is x to the 3 plus 2, or x to the fifth. Now we have minus 4 times minus 3 is positive 12, and x to the third times x to the first power is x to the fourth power. 3 plus 1 is 4. Then we have minus 4 times 6 would be minus 24, and that's x to the third. Then we have 5 times minus 2 is minus 10, and x squared times x squared is x to the fourth. And we have 5 times minus 3 is minus 15, and x squared times x is x to the third. And then we have 5 times 6 is 30, and there's an x squared, 30x squared. Then we have minus 2 times minus 2 is plus 4. X times x squared is x to the third. And minus 2 times minus 3 is positive 6. And x times x is x squared. And then minus 2 times 6 is minus 12. And then there's 1x, minus 12x. And then the next row is very simple, because 1 times minus 2x squared is minus 2x squared. And 1 times minus 3x, of course, is minus 3x. And 1 times 6 is 6. So now we are combining like terms. We're combining like terms. And so there's 8x to the fifth. So 8x to the fifth. And then there's a 12x to the fourth. So let's underline the terms that we've already collected. And we notice here's another x to the fourth, minus 10x to the fourth. So that's taken care of. And those are all the x to the fourth. Then there's a minus 24x to the third, minus 24x to the third. And there's a minus 15x to the third. And there's a 4x to the third here also, plus 4x to the third. And then we have 30x squared plus 30x squared. And we have 6x squared plus 6x squared. And then we have minus 2x squared. And then we have minus 12x. minus 12x minus 3x, and then there's a constant term plus 6. So now, again, we are combining the like terms, and we notice there's only one term with x to the fifth, so it is 8x to the fifth. And then we have 12x to the fourth minus 10x to the fourth, and 12 minus 10 is 2, so 2x to the fourth. And then there are minus 24x to the third, minus 15x to the third, that's minus 39x to the third, plus 4x to the third, and make it minus 35x to the third. And then we have 30x squared. Let me just underline these terms that we've already combined. So then we have 30x to the square, x squared, plus 6x squared, that's 36x squared, minus 2x squared is 34x squared, plus 34x squared. And minus 12x minus 3 would be 3x would be minus 15x, and then there's our constant term 6. So our final answer is then 8x to the fifth plus 2x to the fourth minus 35x to the third plus 34x squared minus 15x plus 6. The next exercise is very similar. We multiply minus 4x to the third times minus 2x squared. So minus 4 times minus 2 is 8. And x to the third times x to the second power is x to the fifth. And minus 4x to the third times minus 3x. Minus 3 times minus 4 is positive 12. And x to the third times x is x to the fourth. And then minus 4x to the third times 6 would be minus 24x to the third. Then we use this term minus 2x to multiply each term in the second polynomial. So minus 2x times minus 2x squared, minus 2 times minus 2 is positive 4. And x times x squared is x to the third. And minus 2x times minus 3x, minus 2 times minus 3 is positive 6. And x times x is x squared. And minus 2 times 6 is minus 12. And then there's only one x there. And then 1 times minus 2x squared is minus 2x squared. And 1 times minus 3x is minus 3x. And 1 times 6 is 6. So when we now combine like terms, we get 8x to the third and 12x to the fourth. There's no other term as x to the fourth. And minus 24x to the third plus 4x to the third is minus 20x to the third. So that's the x to the thirds. And then the 6x squared minus 2x squared is 4x squared. And minus 12x minus 3x is minus 15x, and then there's our constant 6. So this then is the answer to the problem. Number 11. So I wrote the final answer next to the problem. And number 12 is done in the same way. So next is number 12. And again, in principle, it's done the same way. So we multiply a squared times a to the third. And so using the product rule for exponents, it's a to the fifth. A to the fifth. A squared times 3ab. So it would be 3 times a times a squared. That's a to the third b. And then a squared times minus b squared is minus a squared b squared. Then we multiply minus 2ab times a to the third. So it's minus 2. And a times a to the third is a to the fourth. And then this times b. And then minus 2ab times positive 3ab. Well, minus 2 times positive 3 is minus 6. And a times a is a squared. And b times b is b squared. And minus 2ab times minus b squared, minus times a minus is a plus. That's 2a. And then b times b squared is b to the third. And now we need to multiply b squared times these terms here. So plus b squared times a to the third. So we'll change it around in a moment here. And then we have b squared times 3ab. So that's 3ab, and b times b squared is b to the third. And then minus b, or b squared times minus b squared, that's minus, and b squared times b squared is b to the fourth. Again, we add the exponents. So let's look at the terms that we have here. We have a to the fifth, and we have 3a to the third b. And we have minus a squared b squared. And we have minus 2a to the fourth b. We have minus 6a squared b squared. And we have 2ab to the third. And we have a to the third b squared. A to the third b squared. And we have 3ab to the third minus b to the fourth. So let's see what we can combine. There's only one a to the fifth. And then we have 3a to the third b. And that would be the only a to the third b term. So plus 3a to the third power b. And then we have minus a squared b squared minus 6a squared b squared. So minus a squared b squared minus 6a squared b squared is minus 7a squared b squared. And then we have 2a to the fourth b. And that's the only a to the fourth b that we have. Minus 2a to the fourth b. And then we have ab to the third. Two of those, 2ab to the third. And we have 3ab to the third. So 2ab to the third plus 3ab to the third is 5ab to the third power. And then we have an a to the third b squared term plus a to the third b squared. And we have a b to the fourth minus b to the fourth. When you look at the final answer, it seems like some terms look so much alike, maybe we can combine them, but you really can't. Let's look at these two terms here. It's an a to the third b squared minus 7a squared b squared. Well, they almost are the same, but they're not really like terms because here a is raised to the third power and b is raised to the second power. Here a is raised to the second power and b is raised to the second power. So because the a's have different exponents, these are not like terms. Similarly here, we have an a to the fourth b and an a to the third b. The b's are the same with the same exponent, but the a's have different exponents. That's why these two terms cannot be combined. So the reason I'm mentioning it is to have clarity about when terms are like terms. Next, we'll talk about squares of binomials, and the reason why we do that is because the squares of binomials show up in the real world quite often. So here's a plus b squared. A lot of people make the mistake by thinking, oh, that's simply a squared plus b squared. Well, let's see what happens when we write what a plus b squared really means. It means a plus b times a plus b. You know, we multiply the base a plus b by itself. How many times? 2 times. So in other words, the rules for exponents apply also when the base is not a variable or a number, but it could be an expression in parentheses, like a binomial. It could be, for example, a plus b to the third power. Then we multiply a plus b times a plus b times a plus b. But here it's to the second power, so it's a plus b times a plus b. So when we use what we've learned above and multiply these binomials, we get a times a is a squared. And a times b is ab. And b times a is ab also, because multiplication is commutative, so b times a is the same as a times b. And then we have b squared. b times b is b squared. So now we combine terms. And so we have an a squared, and ab plus ab is 2ab plus b squared. So in other words, a plus b quantity squared, in other words parentheses, is a squared plus 2ab plus b squared. It's not simply a squared plus b squared, but we have a middle term. Very, very important detail, so don't fall into that trap that you think, oh, it's just a to the second plus b to the second power. There's a middle term. And the same is true when we have the difference of two terms, a minus b, quantity squared, parentheses squared. What it really means, it's a minus b times a minus b. Again, we use what we've learned above. A times a is a squared. A times minus b is minus ab. A minus b times a is minus ba. And of course, we can write it as minus ab because multiplication is commutative. The order does not matter when we multiply. And so minus b times minus b is plus b squared. Again, we combine like terms. There's only one a squared, but there's a minus ab and another minus ab. So we have minus 2ab plus b squared. So the difference between these two formulas is simply the sign of the middle term. A squared minus 2ab plus b squared when we square minus a minus b. And it's a squared plus 2ab plus b squared when we have a plus b quantity squared. But in each case, we have a so-called middle term. And one of the ways we can use it is by applying it to examples here. So if you multiply a minus b squared, what does it mean? It means a minus b times a minus b, which is really exactly what we had in the example above, except these are lowercase letters, but we know what the answer is equal to a squared minus 2 times a times b plus b squared. So that's one example. And in number 17, we have the problem of x plus 8 quantity squared. So that means x plus 8 times x plus 8. That's what it means. So we know it's equal to the first term squared. In this case, we don't have a, but we have x, so it'd be x squared, plus 2 times the first term times the second term, 2 times a times b. If you look at the previous formula, let me just bring it up for you here again. A plus b squared is a squared plus 2ab plus b squared. So instead of a and b, we have x and 8. So it'd be 2 times x times 8. And then instead of b, we have 8. So b squared would be 8 squared in this case. And so that simplifies then to x squared, and 2 times 8 is 16, plus 16x. And of course, 8 squared is 64. So that would be the answer for this exercise here. Now it gets a little bit more complicated when we have like number 18. So I'm going to explain that in more detail here. And in fact, I'm going to write out the formula again. So that means 3x minus 7 times 3x minus 7. So when you compare that with the formula a minus b squared, and we know the answer to that, or the solution, or the multiplication result, is a squared minus 2 times a times b plus b squared. Okay, so what do we have instead of a? Instead of a, we have 3x, right? The a corresponds to 3x. So when we simply substitute 3x for every a that we see, we get 3x, but again, we need to put in parentheses, squared, minus 2 times, what was a? A was corresponds to 3x. And b corresponds to negative 7. Or to 7 rather in this case, because we already have the minus sign. And then b squared would be simply mean we square b, so plus 7 squared. So in other words, wherever you see an a, you replace it with a 3x. Wherever you see a b, you replace it with a 7. And so what is 3x squared? Well, that's the same as 3x times 3x, and 3x times 3x is 9x squared, and minus 2 times 3 is minus 6, times 7 is minus 42, and then there's the x, and then of course 7 squared is simply 49. So that would be our answer to that particular exercise. 9x squared minus 42x plus 49. Here's a guided solution exercise. So it's m to the third plus 1/4 n, quantity squared. So that means we square the first term, and that would be m to the third squared. And then 2 times the first term, m to the third, times the second term, which is 1/4 n. And then the last term squared 1/4 n to the fourth power, to the second power. Now, remember I mentioned to you the power of a product rule. the power of a power rule, that's where we multiply the exponents. So that's m to the 3 times 2 or m to the 6 power. Again, that's on page 26. And then here we have 2 times m to the 3rd times 1/4 n. Well, 2 times 1/4 is 1/2. 2 divided by 4 is 1/2. M to the 3rd n. So plus 1/2 m to the 3rd n. And then here we square this expression. That means we square 1/4, which is 1/16, and we square n. So that would be n squared. This part here is again on page 26, and it's the power of a product. 1/4 times n is a product. We multiply 1/4 times n. And what that means is that each factor, in this case 1/4 and n, each factor is raised to the 2nd power. So 1/4 to the 2nd power means 1/4 times 1/4, and 1/4 times 1/4 is 16, 1/16 rather, and n to the 2nd power is simply n squared. So that would be the answer. M to the 6th plus 1/2 m to the 3rd n plus 1/16 n squared. Again, you may want to go over this in more detail. Maybe I should write down the rules for exponents here, that a to the m raised to the nth power is a to the m times n. And when we take a power of a product, a times b to the nth power, that means we raise each factor, a and b, a to the nth times b to the nth. Again, these are the rules for exponents you're supposed to know, and you can find them on page 26. So then we'll talk about the product of a sum and a difference. And that's really very simple. In a way, it's a bit surprising, and it's a lot easier than the other rules that we've learned. And again, the reason why this is even discussed is because in many real-world applications, you'll see this kind of a situation where you have the sum of two terms, a plus b, times the difference of two terms, a minus b. And when we work it out, it comes out to a squared minus b squared. And that's the difference of two squares. Why is that? Well, because a times a, of course, is a squared. But a times minus b is minus ab. And b times a is plus ab. And b times minus b is minus b squared. So these terms cancel out. Minus ab plus ab is 0. Therefore, we only have a squared minus b squared, the difference of two squares. In other words, the difference of squares of the two terms. So we're applying that to some of the exercises. So here I wrote the rule for a plus b times a minus b equal to a squared minus b squared. And so for these exercises, all we are asking now is we compare a and b. So what is a and b in this case? Well, compared to the formula, x corresponds to a and a corresponds to b. So therefore the answer is x squared minus 8 squared, or x squared minus 64. Similarly, when we look at number 21, instead of a, we have 4y. Instead of b, we have 7. So if it's a squared minus b squared, we write this then as 4y, but in parentheses, squared, minus 7 squared. Okay? I should put it in parentheses also. So what is 4y squared? Well, it means 4y times 4y, which is 16y squared. And minus 7 squared. 7 squared is 49. And obviously we cannot combine any of these terms because they are not like terms. And number 22 follows the same pattern. So instead of a, we have 2.8 lowercase a, so it'd be 2.8a squared minus 4.1b squared, minus 4.1b squared. So then the final answer would be 7.84a squared minus 16.81b squared. So this formula for the sum and difference of two terms comes in really handy in many ways. And also we'll be using that a lot when we talk about the opposite of what we're doing here when we talk about factoring, but that's for another topic. So here's a guided guided solution problem. And so again, we're looking at the difference in the sum of two terms, 3w minus 3/5 q squared times 3w plus 3/5 q squared. So it means we square the 3w and we square 3/5 q squared. 3/5 q squared. Okay, so let me do a little side calculation just to make it a little more transparent what that is. So this is probably pretty easy. 3w squared simply means 3w times 3w. So it's 9w squared. That's probably the easy part. Now what about 3/5 q squared to the second power? So let me do it over here. 3/5 q squared raised to the second power. Well, it means 3/5, again in parentheses, to the second power, times q squared to the second power. Okay? And so this means 3/5 times 3/5. So that means 3 times 3 is 9, and 5 times 5 is 25. And so here we're having the power of a power, so it means we multiply the exponents. So it'd be q to the 2 times 2, q to the 2 times 2, or 9/25 times q to the 4th. So 9/25 times q to the 4th power. And the other examples are just general multiplication exercises where we cannot really, well, we could use the above example. It's a little bit tricky in this case, but we can do it. It abbreviates things a little bit if we use the product times the sum, the product of the sum and difference. I'll show you in a moment how. The next exercise apparently doesn't have anything to do with what we just did, but when you look at it a little differently, you notice that we have the 2x plus 3 in both cases. So if we rewrote this expression in the following way, parentheses 2x plus 3 minus 5y times 2x plus 3 plus 5y. Now we're multiplying the difference in the sum of two terms. And remember, it's a squared minus b squared. So instead of a, we have 2x plus 3. 2x plus 3, we square that. Instead of b, we have 5y. So minus 5y squared. Again, always use parentheses. Now we learned how to take the square of a binomial. That's a squared. That's, in other words, 2x squared plus 2 times a times b. 2 times a times b, so 2 times 2x times the last term, 3. And then we square this last term. The b squared would be plus 3 squared. And then minus 5y squared. Which then becomes 4x squared. 4x squared. And 2 times 2 is 4 times 3 is 12. 12x. And 3 squared is 9. And 5y squared is 5y times 5y, or 25y squared with a minus sign. So that one was not exactly obvious, so sometimes you have to look at it. Now you could do it differently, and like we've done it before, but this is certainly a faster way of getting the job done. Now the next one is exactly like the example we used before. This is already in the form a plus b times a minus b, except the minus sign is here, but it really applies the same way. So instead of a, we have 7x squared y, so it's a squared minus b squared, 7x squared y squared minus b squared, and b is 2y, so minus 2y squared. So again, we're applying the power of a product. That means we raise each one of the factors, and the 3 factors are 7, x squared, and y. These are all factors. We raise each factor to the second power. So let me write it out as 7 squared x squared to the second power, and then y squared. So each of the factors gets raised to the second power. And then minus 2y squared. Minus, until we raise 2 to the second power, 2 squared, and we raise y to the second power, so y squared. So then we finally get 7 squared is 49. X squared raised to the second power. Remember, we multiplied the exponent, so that would be x to the 4th, and that's simply y squared, minus, and then 2 squared would be 4, and y squared is simply y squared. So the answer here would be 49 x to the 4th y squared minus 4y squared. So for number 26, we notice we're multiplying 3 polynomials together. Now the first one is of the form a plus b times a minus b. So we know that's a squared minus b squared, where a corresponds to 3x and b corresponds to 2y. So in other words, a squared minus b squared becomes 3x squared minus 2y squared. Times 9x squared plus 4y squared. That's this part here. Now, when we evaluate this part here, 3x squared means 3x times 3x would be 9x squared. And then 2y times 2y means minus 4y squared. So that comes from the expression in brackets, times the other polynomial, 9x squared plus 4y squared. And so all of a sudden we realize now that that is another one of the form a minus b times a plus b, except a is now 9x squared and b is 4y squared. So that then becomes 9x squared to the second power minus 4y squared to the second power. And so we square 9 would be 81. And when we raise x squared to the second power, we multiply the exponents, it becomes an x to the fourth minus, and here we square the 4, it becomes 16, and y squared to the second power means y to the fourth power. So that would be the answer to exercise number 26. For the last exercise, using function notation, we're given a function f of x equals x squared plus 2x minus 7. And now we're supposed to determine f of a plus 1 and also f of a plus h minus f of a. Well, what does that all mean? Well, remember for function notation, when we now replace every x with the expression a plus 1. That's what f of a plus 1 means in the context of this function here. So when we expand that, watch what happens. So f of a plus 1, f of a plus 1 means we replace this x with a plus 1. So it becomes a plus 1, but it is squared. So it's a plus 1 squared plus 2 times, and here's another x, so we replace it with a plus 1. And then we have our constant term minus 7. So again, we learned how to square binomials. So a plus 1 squared means a squared plus 2 times a times 1 is simply 2 times a, and then 1 squared is 1. And this gives us 2 times a using the distributive law. 2 times a, 2a, and 2 times 1 is 2, minus 7, and now we combine like terms. So it would be a squared, and 2a plus 2a is 4a, and 1 plus 2 is 3, minus 7 is negative 4. So that's what f of a plus 1 is. So we simply replace every x in the original function with the expression a plus 1. And of course, when we are supposed to determine f of a plus h, that's the same thing except we replace 1 with the letter h. So let's do that. So f of a plus h, what that means, it becomes a plus h squared. Why? Because we're replacing x with a plus h. And then we have 2 plus 2 times x, and x gets replaced with a plus h minus 7. So now we multiply the a plus h binomial expression and raise that to the second power. So it means a squared plus 2 times a times h plus h squared. You may want to go back to the formula where we square a binomial. A plus b squared is a squared plus 2ab plus b squared, except as the b we have an h. And then we have 2 times a using the distributive law, 2a, and we have 2h plus 2h minus 7. So combining like terms, well, let's just do it over here, that becomes a squared plus 2ah plus 2ah AH plus H squared plus 2A plus 2H minus 1. And then we now find what f of a is. Now that's fortunately very simple. F of a. That simply means we replace each x with the letter a. So that becomes then a squared plus 2a minus 7. So now we want to compute the difference between these two expressions. So f of a plus h is equal to this expression here. So f of a plus h minus f of a is then equal to a squared plus 2 times a times h plus h squared plus 2a plus 2h minus 7 minus, so now comes f of a, and that was equal to a squared plus 2a minus 7. So now we have a squared plus 2ah plus h squared plus 2a plus 2h minus 7. Now with a minus in front, we need to change the sign of each of the terms inside the parentheses. So that becomes a minus a squared. That becomes a minus 2a. And this becomes a plus 7. As we combine like terms, we find that a squared minus a squared cancel out. And we have 2ah, and we have an h squared. And so we've had 2a minus 2a, they cancel out. So we have a 2h plus a 2h here. And then minus 7 plus 7 cancel out also. So this then is our final answer, 2ah plus h squared plus 2h. That is the result of computing f of a plus h minus f of a. And this is the end of section 4.2.